Welcome to all for this one of the research setup that is there in the Renewable Energy Lab. This setup is called as solar thermal training system. This solar thermal training system is taking the energy, that is thermal energy, which is present in the sun, to use it for the heating of the water. Here we are having a setup which includes the systems like called as solar flat plate collector, the sun source which is consisted of halogen lights which are having a series parallel of 7 in line, which is having totally of 21 lights, and there is an artificial wind creation on the flat plate solar panels which is done by using a fan. Then there is one more called a collecting tank, which is an insulated one which is going to store the hot water, and there is the top tank which is called as the overhead tank which flows into the collector tank, that is hot water collector. There is one more called the sump tank which is going to collect whenever there is a necessary of the water, which is going to fulfill the necessary of the water. Here the entire system is used to analyze how much amount of intensity with respect to that, how much water is going to get heated up, and what is the time taken to raise the water level for certain amount of duration with then certain amount of intensity. The intensity is usually measured by an intensity measurement meter, which whenever we are going to focus the area which is going to be focused here is this white patch area. This is going to be focused on this. As you can see the reading is going to read as 52. Since it is a lower intensity of that one, whenever we increase the intensity, you can see that the intensity is also going to which is going to be 186 as well as 187. So by using this knob, we are going to alter the intensity level. From 6 am to 6 pm the sunlight varies because the peak is going to obtain at 12 am, as in the afternoon it is keep on reducing. So intensity will not be constant throughout the day. So the wind velocity will also vary. In order to measure the wind velocity, we are having a artificial wind creation. It is nothing but an air blower which is going to blow on the panels. So whenever the heat is going to absorb by the panels, the heat is also lost by convection. This is nothing but a natural convection. This natural convection can be measurable by using the word called as anemometer. This anemometer here we are going to switch on, and this is going to fix the unit. The unit we are going to use it meter per second. Whenever you are going to keep at the center, the rotor is going to rotate and the indicator is going to show the reading. It is nothing but 3.12 or 3.2 meter per second. That is the wind which is going to blow on the solar panel. This is also we are going to take into account. This is the other parameter. First is the solar insolation. Second is the wind velocity. The third one is the angle of tilt. So angle of tilt is usually the panel angle. The panel is going to be fixed, but the sun is keep on rotating. This we can create artificially by rotating this. Whenever we are rotating this, you can see the angle. The angle is 60. Now as we are going to rotate, it is going to be reducing. It is coming near to the 50 degree. Because for different angles we are going to see how the intensity is going to play over the flat plate and how the energy is going to be absorbed by the water. That is second case. Now third case, there is one more. We are also having pump. The pump is used to create a forced convection, but without pump, if we are going to use, we call it as thermosiphon convection in the flow pumps. That is flow of water from the panels. The inlet is on the left hand side and the outlet of the hot water is on the right hand side. This is going to the collector tank and it is once again recycled until unless the temperature of the collecting tank is common. So the front panel is going to display the readings of the temperature at the inlet, at the outlet, pressure at the inlet, outlet, and the flat plate temperature and the flow rate of the water inside the tubes. Thank you very much.